Hello everyone, welcome to this lecture on linear algebra with NumPy. In this lecture, we are going to discuss various built-in functions to work with NumPy for linear algebra operations. So first, let's get started with the matrix multiplication. We can multiply two matrices A and B by applying np dot operator function, or the at operator can be used. For both these operators are used to produce the same result. So we can observe this by creating two matrices A and B. So the first matrix is of size 2 by 2 cross 2, and the second matrix is of size 2 cross 2. And first we are applying np dot function. We passed these two matrices A and B. Now the resultant matrix C gives the result, and similarly we are multiplying these two matrices using the at operator. It performs the same operation and gives a same result like the dot operator. Now we will discuss the matrix inversion, how to implement this matrix inversion using NumPy operator or operation we can see now. So matrix inversion is used to find a matrix that yields the identity matrix when multiplied by the original matrix. So we have a built-in function called INV, linear algebra library, under this NP, that is NumPy package. So we have to compute this inverse of matrix A. So first we have created a matrix A. It is a 2 by 2 cross 2 matrix. Now we are computing the inverse of this matrix by applying this linear algebra function INV, and then we are printing the result. So to verify that the equation, the function gives the correct result, so we can multiply A with its inverse. So by applying this np dot operator, we can multiply A and A inverse and check whether it is giving the identity matrix. The next function is linear system function. We have a equation like Ax is equal to B, where A is a matrix and X is a vector and B is also a vector. So we are taking dot product of A and X, matrix A and vector X. So for example, A contains values 3, 2, 1, 1, 2 in this matrix, and the vector B contains values 5, 5. Let us assume that X contains values like x1, x2, x1, x2. So we can form a linear equation and we can solve them to get the results. So this can be automatically done by the solve function. If you just pass the matrix and the vector B to produce the values of X, so we can implement this code easily. This solves this linear equation. The next function is eigenvalues and eigenvector function. So we can find eigenvalues, eigenvectors. It has many applications. It is widely used in principal component analysis. We can also use this in quantum machine learning, quantum mechanics, stability analysis, and also for various operations. We can compute these eigenvalues and eigenvectors by applying np dot lin alg dot eig function. In linear algebra, under this NumPy, we have a eig function to compute the eigenvalues and eigenvectors of a square matrix. So we will be getting two arrays, one array for eigenvalues and one array for eigenvectors. So the eigenvalues are the roots of the characteristic polynomial equation of A, and the eigenvectors are the directions in which the matrix A scales by these eigenvalues. So first we have to define the square matrix, and then we have to apply this function eig function. We have to pass this array A to matrix A to compute the eigenvalues and eigenvectors, and then we are printing the values, eigenvalues and eigenvectors. To verify this eigenvalues relationship with the eigenvector, so we can have a relationship like A dot V is equal to lambda dot V, where A is a matrix, V is a vector, lambda is eigenvalues, and V is a vector. So we can solve this to get the result. We can apply for each eigenvalue eigenvector. We have to check by multiplying the matrix A by the eigenvector. We have to check whether it yields the same result as multiplying the eigenvalue by the eigenvector. So we can verify this by applying this code. So thank you all. In this lecture we have discussed how to implement NumPy operation functions for various linear algebra operations. Thank you all.